Welding cable can be used for cam lock connections under certain conditions. Let's examine the code requirements and the comparison of welding cable and Type W cable. NEC section 334.10 states that welding cable can be used as general purpose wiring if it is listed for the purpose. UL 62 outlines that welding cables are listed for use in flexible portable cords and cables. NEC section 347.7 states that cam lock connectors are listed for use with flexible cords and cables. Therefore, welding cable that is listed according to UL 62 can be used for cam lock connections according to NEC section 347.7. The welding cable described, which is the Carroll Super Vutron welding cable, has a voltage rating of 600 volts and may be rated for a higher current capacity than Type W cable, but it is not resistant to sunlight or moisture, which may be a concern for outdoor use. Type W cable is rated for 2000 volts and is resistant to sunlight and moisture and is also more flexible than welding cable. For this application, either welding cable or Type W cable can be used. However, if the cam lock connections will be exposed to sunlight or moisture, Type W cable is a better choice. In conclusion, welding cable can be used for cam lock connections if it is listed for the purpose, such as the Carroll Super Vutron welding cable that was described. However, for outdoor use or in environments where sunlight or moisture may be present, Type W cable is the more suitable option. When deciding between welding cable and Type W cable for cam lock connections, several factors should be considered beyond just the code compliance. Firstly, consider the specific application. Are the cam lock connections primarily indoors, outdoors, or a mix of both? For indoor applications where sunlight and moisture are minimal, welding cable may be suitable if it meets the necessary UL listing and voltage requirements. However, for outdoor applications or environments with potential exposure to sunlight or moisture, Type W cable is generally the preferred choice due to its superior resistance to these elements. Secondly, evaluate the flexibility requirements of the installation. Type W cable is typically more flexible than welding cable, which can be advantageous in situations where frequent bending or movement of the cable is necessary. Consider the ease of installation and handling when making your decision. Thirdly, check the ampacity of both cable types to ensure they can handle the intended load. While the specific welding cable mentioned may have a higher current capacity than some Type W cables, it's crucial to consult the manufacturer's specifications and relevant NEC tables to determine the appropriate cable size for the application. Ensure that the selected cable meets or exceeds the ampacity requirements to prevent overheating and potential safety hazards. Fourthly, assess the voltage drop. Longer cable runs can result in significant voltage drop, which can negatively impact the performance of connected equipment. Calculate the voltage drop for both cable types based on the length of the run, the load current, and the cable's impedance. Choose the cable that minimizes voltage drop to ensure optimal performance. Fifthly, consider the overall cost. Welding cable may be less expensive than Type W cable in some cases, but it's important to factor in the long-term costs associated with maintenance, replacement, and potential safety issues. Type W cable's superior durability and resistance to environmental factors may make it a more cost-effective option in the long run, especially for outdoor applications. Sixthly, review the local electrical codes and regulations. While the NEC provides a general framework for electrical installations, local codes may have additional requirements or restrictions that could impact the selection of welding cable or Type W cable. Consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes. Seventhly, examine the voltage rating. The Type W cable is rated for 2000 volts. While the welding cable is rated for 600 volts. Consider the system voltage to ensure the cable's voltage rating is adequate. Using a cable with a voltage rating lower than the system voltage can lead to insulation breakdown and potential hazards. Eighthly, consider the environment where the cables will be used. If the environment contains oil, chemicals, or other substances that could degrade the cable insulation, choose a cable that is specifically designed to withstand those conditions. The Carroll Super VU-Tron cables mentioned are oil resistant, but it's important to verify that they are compatible with all potential contaminants in the environment. Ninthly, look into the ease of termination. Ensure that the cam lock connectors are compatible with the selected cable type. Some connectors may be designed for specific cable sizes or types, so it's important to verify compatibility before making a purchase. Proper termination is essential for ensuring a safe and reliable connection. Tenthly, assess the ampacity dirting. When cables are installed in conduit or bundled together, their ampacity may need to be derated to prevent overheating. Consult the NEC tables to determine the appropriate dirting factors for the specific installation conditions. Choose a cable size that accounts for any necessary ampacity dirting. In summary, selecting the right cable for cam lock connections involves a comprehensive assessment of various factors, including code compliance, environmental conditions, flexibility requirements, ampacity, voltage drop, cost, and local regulations. By carefully considering these factors, the most suitable cable can be picked for the specific application, ensuring a safe and reliable electrical system. Furthermore, let's delve deeper into the specific NEC articles and UL standards that govern the use of welding cable and Type W cable in cam lock connections. A more thorough understanding of these regulations can help ensure compliance and prevent potential safety hazard. NEC Article 400 covers flexible cords and cables, including welding cable and Type W cable. This article outlines the permitted uses, restrictions, and ampacity requirements for flexible cords and cables. It's important to carefully review Article 400 to ensure that the selected cable meets all applicable requirements. NEC Article 310 addresses conductors for general wiring, including the installation of conductors and conduit. This article provides ampacity tables for various conductor sizes and insulation types, as well as dirting factors for ambient temperature and the number of conductors in a raceway. When installing welding cable or Type W cable in conduit, it's essential to comply with the requirements of Article 310 to prevent overheating and potential fire hazards. UL Standard 62 specifies the requirements for flexible cords and cables, including welding cable and Type W cable. This standard covers various aspects of cable construction, performance, and safety, including insulation thickness, conductor stranding, voltage rating, and resistance to environmental factors. Cables that comply with UL 62 are marked with the UL listing mark, indicating that they have been tested and certified to meet the requirements of the standard. UL Standard 1581 outlines the test methods for electrical wires, cables, and flexible cords. This standard includes tests for tensile strength, elongation, heat resistance, oil resistance, and other properties. Cables that meet the requirements of UL 1581 are considered to be suitable for use in demanding applications. When selecting welding cable or Type W cable for cam lock connections, it's important to verify that the cable complies with all applicable UL standards and that it is marked with the UL listing mark. This ensures that the cable has been tested and certified to meet the necessary safety and performance requirements. In addition to the NEC and UL standards, it's also important to consider any applicable local codes and regulations. Local codes may have additional requirements or restrictions that could impact the selection of welding cable or Type W cable. It's always best to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes. Let's discuss the practical considerations for installing welding cable and Type W cable in cam lock connections. Proper installation is essential for ensuring a safe and reliable electrical system. Firstly, choose the right size of cable. Ensure that the cable is sized appropriately for the intended load current and voltage drop. Consult the NEC tables and manufacturer's specifications to determine the correct cable size. Secondly, prepare the cable ends. Carefully strip the insulation from the cable ends without damaging the conductors. Use a cable stripping tool to ensure a clean and accurate strip. Thirdly, install the connectors. Use cam lock connectors that are specifically designed for the selected cable type and size. Follow the manufacturer's instructions for installing the connectors. Fourthly, torque the connections. Use a torque wrench to tighten the cam lock connectors to the specified torque. Over-tightening or under-tightening can lead to loose connections and potential safety hazards. Fifthly, test the connections. After installing the cam lock connections, use a multimeter to verify continuity and insulation resistance. This ensures that the connections are properly made and that there are no shorts or ground faults. Sixthly, protect the cables. Protect the cables from physical damage by routing them through conduit or cable trays. Secure the cables to prevent them from being pulled or strained. Seventhly, label the cables. Label the cables with their voltage and current ratings. This helps to prevent accidental overloading and ensures that the cables are properly identified. Eighthly, inspect the installation regularly. Periodically inspect the cam lock connections for signs of wear, damage, or loose connections. Repair or replace any damaged components immediately. In summary, proper installation is crucial for ensuring the safe and reliable operation of cam lock connections. By following these practical considerations, the risk of electrical hazards can be minimized and a long-lasting electrical system can be ensured. In addition to the aforementioned factors, it is paramount to address the specific environmental conditions prevalent in television production trucks and theater lighting setups. These environments often present unique challenges that can impact the performance and longevity of electrical cables. Firstly, temperature fluctuations. Television production trucks and theaters can experience significant temperature fluctuations, especially during performances or outdoor events. Welding cable and Type W cable should be selected with temperature ratings that are appropriate for the expected range of temperatures. Cables that are not rated for the expected temperatures can become brittle or degrade over time, leading to insulation breakdown and potential safety hazards. Secondly, exposure to chemicals and solvents. Television production trucks and theaters may contain a variety of chemicals and solvents such as cleaning agents, paints, and lubricants. Welding cable and Type W cable should be resistant to these chemicals and solvents to prevent degradation of the insulation. Thirdly, mechanical stress and abrasion. Cables in television production trucks and theaters are often subjected to mechanical stress and abrasion due to frequent movement, bending, and handling. Welding cable and Type W cable should be durable and flexible enough to withstand these conditions. Cables that are not resistant to mechanical stress and abrasion can become damaged over time, leading to shorts, ground faults, and other electrical hazards. Fourthly, presence of moisture and humidity. Television production trucks and theaters may be exposed to moisture and humidity, especially during outdoor events or in poorly ventilated areas. Welding cable and Type W cable should be moisture resistant to prevent corrosion and insulation breakdown. Fifthly, electromagnetic interference, or EMI. Television production trucks and theaters may contain a variety of electronic equipment that can generate electromagnetic interference. Welding cable and Type W cable should be shielded to prevent EMI from interfering with the performance of sensitive electronic equipment. Sixthly, physical space constraints. Television production trucks and theaters often have limited space for cable routing. Welding cable and Type W cable should be flexible and compact enough to fit into tight spaces. Seventhly, compliance with safety regulations. Television production trucks and theaters are subject to strict safety regulations to protect the health and safety of performers, crew members, and audience members. Welding cable and Type W cable should comply with all applicable safety regulations to minimize the risk of electrical hazards. In summary, television production trucks and theaters present unique environmental challenges that can impact the performance and longevity of electrical cables. By carefully considering these environmental factors when selecting welding cable and Type W cable, a safe, reliable, and durable electrical system can be ensured. Remember that the ultimate decision on whether to use welding cable or Type W cable depends on a comprehensive evaluation of the specific application requirements, environmental conditions, and applicable codes and regulations.